Dear students, in this lecture we will discuss about Fourier series for discontinuous function. Suppose fx be a discontinuous function in the interval c less than equal to x less than equal to c plus 2 pi. And suppose x0 be the point of discontinuity, then the function fx is defined by fx is equal to, suppose the function fx is defined by fx is equal to gx when c less than x less than c x0, and fx is equal to hx, and suppose these two are two functions of x, and it is defined when x0 less than x less than c plus 2 pi, and where x0 here x0 is the point of discontinuity, the interval where the x0 is the point of discontinuity in this interval. And suppose in the xy plane we can see here x-axis, y-axis. Suppose this is the point of this p is the point of discontinuity, that is x equal to x0, and suppose this is the shape of the curve between c to x0, and this is the shape of the curve between x0 to c plus 2 pi. Okay, this is the point of discontinuity. Okay, now the values of the coefficient for the Fourier series can be expressed as, here x0 is the point of discontinuity, then how we will find out a0 equal to 1 upon pi x0 to c to x0, here function is dx gx, plus x0 to c plus 2 pi function is hx, and formula of an is 1 upon pi n is 1 upon pi c to x0 gx cos nx dx plus x0 to c plus 2 pi hx cos nx dx, and we will calculate vn equal to 1 upon pi c to x0 gx sin nx dx plus x0 to c plus 2 pi hx sin nx dx. Okay, here at the point x equal to x0 there is a finite jump in the graph of the function. Both the limit, that is right hand limit here slightly less than right hand limit slightly greater than x0, and slightly left hand limit, that is slightly less than x0, right hand limit, that is f of x0 plus 0, and left hand limit, that is f of x0 minus 0 of fx at x equal to 0 exist but are unequal. Okay, the value of the function Fourier series at x equal to x0 is the arithmetic mean of these two limits, that at x equal to x0, that is 1 upon fx equal to 1 upon 2 f x minus 0 plus f x0 plus 0, that is value of function at slightly less than x0 is the point of discontinuity, and value of the function at slightly greater than x0, that is we can say 1 by 2, this is pb plus pc, and suppose arithmetic mean of these two is pm. Okay, in such a way we find out Fourier series for the discontinuous function. Let us have a problem for discontinuous function. Suppose we have this problem. Obtain a Fourier series for this function. Obtain a Fourier series for the function fx is equal to x in the interval minus pi less than x less than 0 and minus x when 0 less than x less than pi, and hence show that 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to pi square upon 8. And we know that Fourier series is defined by the formula. We know that fx is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Okay, and suppose this is the equation 1. Here a0, an and bn are Euler's coefficients, okay, which we have to calculate one by one for this discontinuous function. Here x equal to 0 is the point of discontinuity. Okay, here x equal to 0 is the point of discontinuity. Now how we will find out a0? a0 equal to 1 upon pi, this is minus pi 2 plus pi fx dx. Okay, but here x equal to 0 is the point of discontinuity. That is, now we can divide here minus pi to 0. Here we have function x dx, and plus 0 to pi we have fx equal to minus x dx. That is a0 equal to 1 upon pi. Now we integrate this. Integration of x is x square upon 2 and limit is minus pi to 0 plus integration of this is minus x square upon 2, limit is 0 to pi. That is a0 equal to 1 upon pi Now first we apply upper limit. Upper limit is x equal to 0, this term will be 0. Next we apply lower limit, x equal to minus pi, that is minus pi square upon 2. Here we have minus pi square upon 2 plus, when we put x equal to pi, here we have minus pi square upon 2 minus minus plus, when x equal to 0 it is 0. On solving this we get here 1 upon pi into minus 2 pi square upon 2, minus pi square minus pi square. Now 2 cancel out and pi's cancel out, a0 equal to minus pi. Okay, now next we find out next Euler's coefficient an. Formula of an is 1 upon pi minus pi 2 plus pi fx cos nx dx, that is 1 upon pi, and here function is defined fx equal to x when minus pi to 0 and minus x when 0 to pi. First we take the limit minus pi to 0. Here we have x cos nx dx plus 0 to pi, here we have minus x cos nx dx. That is, now we integrate by parts for both the integration. In first integration, this is the first function and this is the second function. Now first function, that is x, integration of cos nx. Integration of cos nx is sin nx upon n minus differentiation of first and integration of cos nx. Cos nx, integration of cos nx is minus sin nx. Okay, minus sin nx upon n, that is integration of this we get minus sin nx upon, first function into integration of second minus differentiation of first and integration of sin nx is cos nx. Here we have cos nx, this is cos, minus cos nx upon n square, and here limit is minus pi to 0, plus second function, first function, that is minus x, integration of cos nx. Integration of cos nx is sin nx upon n minus differentiation of first, that is minus 1, and integration of second, that is minus cos nx upon n square, and here limit is 0 to pi. Okay, now an is equal to, now we can say this minus and this minus means we can put here plus sign. Okay, and these two minus are cancel out. Here we have x equal to minus x, differentiation of this minus 1, and integration of this term is minus, so this two sign will be plus. Okay, now we apply the limits. Here upper limit is x equal to pi. When we put x equal to 0, when we apply upper limit x equal to 0, it is 0 into sin 0, 0, plus cos 0 means 1 upon n square, cos 0 is 1, minus, when apply x equal to minus pi, minus pi into sin minus n pi, sin minus theta is plus sin theta, that is sin n pi, and again we have sin n pi is 0, sin n pi is 0. Okay, that is first term is 0, plus cos n pi, cos minus theta is minus cos theta, and cos n pi is, what is the value of cos n pi? Cos n pi is minus 1 to the power n. Cos n pi is minus 1 to the power n upon n square. Okay, plus first we apply upper limit. Upper limit is, here upper limit is x equal to pi, sin n pi is 0, this is 0, minus cos n pi, again it is minus 1 to the power n upon n square, minus, when x equal to 0, lower limit, x equal to 0, first term is 0, minus cos 0 is 1 upon n square. Okay, that is an is equal to 1 upon pi. What we have here, Here we have 1 upon n square minus 1 to the power n minus 1 to the power n upon n square. Here minus 1 to the power n upon n square, and minus plus, that is 1 upon n square. Okay, that is 1 upon n square is the common term. Here we have 2 minus 1 to the power n. Okay, that is 2 is the common term. 2 equal to 2 upon pi n square, and here we have 1 minus 1 to the power n. Okay, and equivalently we can write it when n is even function. When n is an even number. When n is even number means it is minus 1 to the power 2, that is 2, 4, 6, means minus 1 to the power even number means plus 1, and by 1 minus 1 will be 0. And when n is odd, means here we have minus 2 upon pi n square. When n is odd, it is minus 1 to the power minus 1. Okay, minus 1 to the power 1 means it is minus plus, that is 2. It will be 4 upon pi n square. Okay, next we find out Bn. Now how we will find out Bn? Formula of Bn is equal to 1 upon pi minus pi 2 plus pi fx sin nx dx, that is 1 upon pi. Now integration is divided in two parts, that is minus pi to 0 we have function x, here we write x sin nx dx, plus 0 to pi we have minus x sin nx dx. Okay, 1 upon pi. Now we have to integration by parts for both the integration, taking this x as a first function and sin nx in second function for the first integration, and minus x is the first function and sin nx is the second function for second integration. Now we integrate this first function, that is x. Integration of sin nx is minus cos nx upon n. Minus differentiation of this x is 1, and integration of this term is minus sin nx upon n square, and limit is minus pi to 0 plus. Now second integration, first function, that is minus x, and integration of sin nx. Integration of sin nx is minus cos nx upon n, minus differentiation of first minus 1, integration of second is minus sin nx and this upon n square, and limit is 0 to pi. Okay, now we apply this limit. Here upper limit is x equal to 0. Okay, means when we apply upper limit in first part, x equal to 0 into anything 0. Here minus minus, we can change this sign, minus minus plus, and sin 0 is 0. Minus lower limit when x equal to minus pi, when x is equal to minus pi, what we have here? Now we put x equal to minus pi. Here we have minus pi and cos minus n pi, and we know that cos minus theta is plus cos theta, that is cos n pi. And what is the value of cos n pi? Cos n pi is minus 1 to the power n. Cos n pi is minus 1 to the power n. It is when x equal to pi, it is minus pi. See here, when x equal to 0, this is 0, sin 0 is 0, minus lower limit x equal to minus pi, this is minus pi, and minus cos minus pi, that is minus of minus 1 to the power n upon n. We have this term here, and plus sin minus n pi, and sin n minus theta is minus sin theta, and sin n pi is, what is the value of sin n pi? Sin n pi is 0. When you are going to solve any problem of Fourier series, you should know about all these values. Okay, here n is positive integer, here n equal to 1 2 3 4 5, and we get this kind of values. Means when we put x equal to minus pi here, we get here 0 term, plus. Now we apply upper limit. Here upper limit is minus pi, and here minus cos n pi. Minus cos n pi is minus 1 to the power n upon n. Okay, this minus and this minus, we can cancel out these two minus. This is plus, means minus sin n pi is 0, minus. Next we apply lower limit. Lower limit is 0 when x equal to 0. First term 0 into anything 0, and second term is sin, we have sin nx, means second term again 0. That is bn is equal to 1 upon pi. What we have here? We have here these two sign, we can cancel out. Here we have minus pi upon n, minus 1 to the power n, and here these two minus, we can say these two cancel out, and here we have plus pi upon n, minus 1 to the power n. Okay, means negative term and positive term cancel out, means Bn equal to 0. Okay, now from the Fourier series we know that from equation 1 fx is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Okay, that is fx equal to, what is the value of a0? Value of a0 is minus pi, and value of an is this. Okay, now we substitute value of a0, an and bn in this equation. What we have? a0 equal to minus pi means minus pi upon 2 plus what is nn? Here we get term when n is odd only. Okay, when n is even, then all term will be 0, or we can write it summation n equal to 1 to infinity summation n equal to 1 to infinity, and value of n is 2 upon pi n square 1 minus 1 to the power n plus summation n equal to 1 to infinity bn is 0 sin nx. Okay, that is what we have. Fx equal to minus pi by 2. When we put n equal to odd, n equal to even number, then we get 0 here. We get terms only when n is odd. Now what we have? When n is odd means here we have every time plus 2. Okay, that is 4 upon pi. Here we have, when we have n equal to 1, it is cos, here one term is left, into cos nx. Okay, cos nx, here this term is left here, cos nx means into cos x upon 1 square plus cos 3x upon 3 square plus cos 5x upon 5 square, and so on. Now what is the value of function at the point of discontinuity? At the point of discontinuity, here x equal to 0 is the point of discontinuity. Okay, now we have to find out f0, which is equal to fx. What is the value of function fx? That is 1 by 2 f x0 plus 0 plus f x0 minus 0, that is 1 by 2. When we have value slightly greater than 0, what is the value of function when slightly greater than 0? So definitely when it is slightly greater than 0, it is almost equal to 0. When slightly less than 0, it is 0. That is, function is 0. Okay. That is, at the point of discontinuity, this is 0. Now this is the equation number 2. Now we have to find out this result also. For this, now putting x equal to 0 in equation 2, and when x equal to 0, we have f0 is 0. This is equal to minus pi by 2 plus 4 upon pi. Cos 0 is 1, that is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, and so on. On solving this, that is 4 upon pi, 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to pi upon 2, that is 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to pi square upon 8, which is a final answer. I think this method is clear to all of you. If you have any queries regarding this Fourier series for discontinuous function, you can comment on comment box. Thank you very much.